Okay, so hello all. So today we're going to have a look at some AI, and we're going to be looking at something called Olama, and we're also going to be having a look at these large language models. So if you think of the brain and you think about what's in your brain, you can think of a large language model that way. And we're going to be using something called Dolphin to do that. And we're going to be looking at something called Dolphin with Llama 3, and we're also going to be looking at Qwen 2.5 as our large language models. We're going to be using Linux to do that. And we're going to be using promox as well as the NVIDIA GPUs to help us along with the computation. And we're going to be using Docker as well. Cool. So this setup already assumes that you have installed promox, you have some industrial GPUs. I'm using a P100. If you want to see how that's done with a P100, refer back to my other video. And essentially, we're going to be using the AI to kind of do some prompt engineering, which means that we're going to ask it some questions, see what the results are based upon different things. So for example, air law meteorology, and we're going to be using that as a reference, for example. So we could say, well, okay, what are the rules of the air, for example? That sort of thing. What else can you use it for? Well, besides that, you can use it to do some research. For example, if you have your own model, you want to train your own model, you could use Olama for that, which is what we'll be using in order to load up the models. And on top of that, we can also use it as a deterrent towards the cloud. So for example, the cloud's getting expensive and you want to just use a small subset, then on-premises kind of makes sense because you pay for the cost of electricity. And of course, you can also try out different models. In the cloud, not necessarily. You're kind of bound to the ones that they give you. AWS, for example, has Claude. Google, I know, gives you a bit of flexibility with its tensor processors. So you could use TensorPy, I think it's called, or PyTensor. And yeah, on top of that, it's fun. You also get to learn kind of how the AI works without having to worry about timeouts or restrictions around tokens, for example, because you might have a certain limit. So you can get around it using an on-premises system. Cool, so that's enough riffraff. And essentially what we'll be doing is loading up Ubuntu. So I'm assuming you've got promox installed. I'm assuming you've got your cards installed. If not, as I mentioned already, go and have a look at my video, which will go into more detail as to how that's done. For now, let's get into it. Right, first thing that you want to do is you want to go down to Data Center and you want to click on Create VM. In here, leave the ID the same. All you want to do is just load up a name. So in my case, it's Olama AI. Resource pool will keep as default. Next, and we're going to select our OSI image, ISO image even. Say OSI image. What's going into me today? We're going to do 22.04. That's the one which I have. If not, I'll load it into your promox system and use that or use a physical CD. I'm going to leave everything else the same. Next, machine. Well, for some reason, my system defaults to i440FX. That's the old system, which uses PCI. We don't want that. We want PCI Express. Q35 it is. Next, disks will keep everything the same except for the disk size. We're going to make that 500 gigabytes. I've got 1 terabyte on here, so for me that's fine. Keep everything else the same. CPU. Cores, I'm going to select as 20 because I've got 32 cores in the system. I believe I do have 24. I might have 24 actually. I might have 24. Anyway, we'll keep that as 20. Type, right. For the type, this depends on what you want to do. You can have emulation. So you can emulate a particular type of CPU, which could give you access to different instruction sets. Now, the main one that you want is AVX if you have multiple GPUs, because the way Olama works, it looks for AVX extensions. So that means that if your processor doesn't support AVX extensions, you can't really use the GPU unless you're using an AMD one, which may support something else. For me, my processor, which I have inside of the system, supports AVX. So I'm going to go with host because it becomes a bit easier and it's simpler for me and quicker to just pass in the host CPU type, essentially. Next, memory, I'm going to give it about 80 gigs. Why 80 gigs? Because the way I like to think of it is wherever the size of the large language model is, then times that by 2. So Dolphin, for example, Llama 3 is about 40 gigs. So I'm going to give it 80 to store the entire model in its entirety. And then with that, then you can utilize the extra memory that you have to work with, to do computation. So what have I got? So I should have 5 zeros here. So I've got 1, 2, 3, which is 8 gigs, 80 gigs, 4 zeros, right? So 80 megs, 800 meg, 80 gig, 8 gig, and then 80 gig. Next. Now I have a virtual bridge in Proxmox, which means that I binded the ports together to create one bridge. So if you look at the back of your kind of laptop, you see that thing that you can plug into your router, which is the Ethernet cable with an Ethernet cable. I've got 4 of those binded together. They're fiber optic. They go towards a switch. Now, the switch is just kind of like a distribution point for networking traffic. And then that connects back up to my pfSense system, which is my router. Yeah, and that goes back out to the internet. I'm going to give it a VLAN tag because my system is separated by VLANs. And all that means is if you think of like people shouting inside of a room, all of them are in separate rooms, as opposed to everybody being in the same room where everybody's shouting, because the VLAN separates out the broadcast, because it's a virtual local area network, right? A virtual local area network. So as a result, you just put down as 4, because I have 4 and 5 within my network. I'm going to put it down as 4. I'm going to click next. You may not have that, so don't worry about it. You can just have VLAN 1. It's not a problem. And I'm just going to click on next. Okay, I have a question mark on mine. That's it. Oh, there we go. It's now got it in. So 80 gigs is about 78 gigs of RAM. That all looks good. The next point is to add the graphics cards. So you go down to add, and then you go to PCI devices. And then from here, look for your GPU. Mine is 2, so I've got 2 P100s. And my MDev type is going to be 1 because I want the entire frame buffer. I'm going to add it. And on top of that, I'm going to click on PCI Express. I didn't realize that in my previous versions of this video. But essentially that means it acts, rather than a PCI device, it acts as a slightly faster PCIe device, which is what we want. We want a 1-to-1 mapping because it's linked in via PCIe. So I'm going to click add for that. And then I'm going to pass through my second PCIe device, which is my second graphics card. And I'm going to go to PCI device and look for my second one. My MDev type is 1, PCIe, add, job done. Next, I'm going to start the system. I'm going to go to console. And it should start in a minute, all being well. I might need to restart the system because we were in use a bit earlier on. Yep, here we go. Is not available. 81. So I passed through the same one twice. That shouldn't have been possible. So I need 87, I think is the other one. There we go, C1, even better still. Okay. That should fix that problem. Let's start the system. It says okay. Okay, there we go. That's what I wanted. Okay. Gonna try it. Load that up. Shouldn't take too long. I'm going to come back when that's loaded. Okay, welcome back. So I've got a screen now, and I'm going to just show you my settings. So English UK, update to new installer. This won't take too long. And it should do the cloud init. There we go. Done. Done. I'm going to just use the default IP that it gave me. Done. Done. This should be pretty quick because we already know it has internet. Done. Done for this. So if I'm saying done, it means leave it as default. And edit for this. I'm going to type 497 996. Why am I doing that? Well, the reason why is because I don't want to extend the root partition anymore. So the root partition is the main part of the system. Think of it like a B, C, D, as you would do in Windows. This is like the C drive, which is the main one. And I don't want to extend it more than I have to. I don't want to have like A, B, C, D, for example. I just want one drive. Makes things a bit easier and a bit more efficient, at least in this setup. In production, you might have different partitions, but for the purposes of this demo, I think it's fine. Save. That looks good. I'm going to go down to done. Yep, that's fine. Continue. My name. Server name is going to be Olama AI. My username is DC, and my password is my password. And that looks good. I'm going to continue. Now, I recommend installing the OpenSSH server because that gives us terminal access. Done. Done. View full log. I'm going to let that simmer, and then I'll come back. Okay, welcome back. So I'm going to reboot. Don't worry about the error message. If it says failed, just press enter. It's fine. And that will boot up into Linux, which is awesome. And with that, we're going to do two things with that. So as that's loading, I want to make you aware that we will need to install the client-side GPU drivers. So why do we need to do that? Well, we need that in order to utilize the GPUs which are inside of the system. And what that means is if you look at a GPU in itself, it can do two things, right? One is display information on the screen, and then the other one is to crunch information on the screen. So by doing that, what we're doing is we're telling the system to utilize those GPUs which we pass through. So remember those PCI devices that we sent into the system, those P100s? We need to find a way of utilizing them. So this driver, in this sense, is going to be the glue that enables us to do exactly that. Instead of it being not known, we're going to make it known to the system that they exist. Now, we installed OpenSSH on the system. So what we're going to do is we're going to now actually access the system through the terminal instead of the console. That means that we get to copy and paste things between our clipboard into the system, which is better. In console mode, we can't do that. So I believe that was on an IP address of 192.168.4.10, I think the IP address was. Yes, it was. Okay, I'm going to log in. And let's just do a couple of housekeeping things. Sudo apt update the repositories, and we're going to do a sudo apt upgrade. Upgrade every package, depending on what's in the repository. Type in my password, and I'm going to let that continue. Okay, this shouldn't take too long. And as that is going on, I'm going to just let that continue, and then I'll come back. Okay, so when we do the update, sometimes what will happen is that you'll be presented with this demons using outdated libraries message. I'm going to keep this as default, so I'm just going to OK it, and that will give us the terminal back again. Now I'm going to secure copy over my Linux driver to the system. I'm going to press enter, and this is the command that I'm running. Yes, password. Let it do its thing. Won't take too long at all. And it's done. Sweet. Now, before we can utilize it, let's make sure that we have our GPUs listed through an lspci -v command. And I can see here that we have our GPUs passed through, but we're not using the NVIDIA driver. We have the modules loaded, which are nvidia-fb and Nouveau for both different drivers. So what we need to do is install the driver now. I've already sent it towards the system, and it's inside of the home directory, as seen here. But before we can actually install the driver, because it's going to look for GCC, we need to install certain packages to get GCC to build. So first thing we want to do is blacklist the Nouveau driver, and we do that with the following command: echo blacklist Nouveau into modprobe-d. Next part is to echo Nouveau modset into a blacklist Nouveau file. So again, making sure it doesn't load up. Then we're going to update init ramfs. This will take a little bit of time, but nothing too heavy. So we'll, yep, see, there we go, it's already updated. And now we're going to reboot. Okay, that's not going to take too long either, because, like I say, this is just going to restart. So we can just check the console, just make sure it's going through all right, and it is. Okay, so as that's going on, what we'll do is we'll reconnect to our system. Okay, now that that part's done, we'll check to see our PCIe cards are still there, which is our GPUs. Yep, I can see that we have successfully stopped the driver, which is good. We've blacklisted it. Now we need to install the NVIDIA driver. So first things first, update our repositories through a sudo apt update, and then we're going to install certain packages. Our packages that we're going to install are listed as build essentials, libl vnd-dev, and package config, right? pkg config. So we're going to do an apt install, and then go to the end, type -y to accept any prompts, and password, and we're going to let that install. And the reason why I'm getting that error is because I need sudo in front of the apt install. Okay, which means that we now have permissions to install. Shouldn't take too long. And then we'll do an lspci when that's done. So I'm just going to let that continue, and we'll pick up in a second. All right, cool. So the next part is to install our graphics card driver, which in this case is the NVIDIA Linux x86 583.161.08-grid run. A mouthful, I know. Why this particular file? So this particular file, because this is the Linux client driver. There's a server driver to this as well, and check out my other video where I go into a lot more detail about that. Okay, where I go into the installation of this, and it shows you how to install the P100s and set them up. Of course, make sure that you have adequate cooling for the P100s. When I did that video, I did not. I've since got a couple of fans, bolted them on, and it works just fine. Now, the other reason why you want to install the driver is because if I do an nvidia-smi, you'll notice that it tries to look for the particular packages which associate to nvidia-smi, but it's not installed locally. This particular driver has it installed. Okay, in other words, it will install it, which is another reason why we need it there. So we can also access the CUDA libraries which are needed for AI to run. So let's install the graphics card driver. Now, forget about this message. It's just saying that there's an alternative method, but we've already proved that what we need isn't there. So we'll continue with the installation. And it's going to build out those particular modules that we need so that it can work. So we'll just give it a minute. Again, won't take too long. And it's going to say that these are not queryable, but I wouldn't worry about that. I'm pretty sure we installed pkg config as well, so I'm not going to worry about that. Install 32-bit compatibility libraries. With this, we don't necessarily need it as a running AI, so I don't think we need to. Don't worry about Vulkan. We don't need Vulkan, and we just need to install this driver now. Again, this won't take too long, so should be okay. NVIDIA xconfig utility to automatically update your configuration file so that NVIDIA X driver will be used when you restart X. Yeah, we can use that. I think that's fine. It has been updated successfully. Cool. So now if I do an nvidia-smi, there we go. I can see both drivers. And we've installed the correct CUDA version, which is 12.2. So let's do another CPU to check our AVX compatibility. And yes, I can see that I passed in my host as well. So I can see that my CPU is set up correctly. And the instruction sets that we need in order to run Olama are there out of the box, which is great. The next thing that we need to do is to install Docker. So what we do here is we go to the Docker website because we're going to need this to install Compose. So I am going to put this here. Okay, cool. I'm just going to go to the Docker website, Docker, and we want to look for the Ubuntu repo. Docker apt install, because I've got aptitude. So this is Docker engine. And we want to copy this. This is all the commands that we need to update from the repo. And we're going to create a little script. So we do vi docker.sh, and in here, let's put that all in there. Go up with gg hash bin bash. Why we're doing it this way? Because it's just easier to get it all done, to be honest. There's a lot of commands there, and we're just going to make a couple of adjustments. Do a -y to accept all prompts, and I'm just going to go back and also copy this across. So this installs Docker, BuildX, all of those good packages that we need. And I'm also going to add, if it will let me. Okay, there we go, a -y. Make it executable with a chmod +x, changing the mode to make it executable, and then we're going to do our run against Docker sh, which will install the Docker packages that we need. Okay, I'm going to come back when that's done. Okay, now that that's done, what we need to do is we need to now git clone Olama. And the version that we're looking at is Olama Docker from Villaintinix. I think that's how you say that. I don't know how you say that, but I'm guessing that's it. And the one that we're looking for is the Docker Compose Olama GPU. Okay, and we're going to run it in the following manner. We're going to git clone it, first of all. We need to also make sure that we have the GPU support in there as well, which means that we need to install the NVIDIA Container Toolkit. We're going to come back to that. we're going to come back to that. But for now, we just need to clone it out. Okay, so let's do a git clone on that. cd Olama, and in here we need to do a tweak, which is vi docker compose Olama GPU, and you'll see that there is a count here of 1. I have 2 GPUs, remember, from nvidia-smi. So I'm going to put that down as 2 and right quit. So that's colon right quit. And we now need to install the NVIDIA Container Toolkit. Now, I don't recommend doing it this way. What I would recommend is that if you go back to Olama, so a page here for Olama, or even better still, just go down to Olama, Docker Compose, and it should say in here, there's supposed to be a, there is a bit in here which says NVIDIA Container Toolkit. But we need the, oh, here we go, I've got it here open, NVIDIA Container Toolkit. So you need to go to this, installing NVIDIA Container Toolkit, and utilize this section of the code from this particular page, because this is from NVIDIA, so this is the actual bit that we need, right? So first thing that we're going to do is we're going to install the NVIDIA Container Toolkit package, and we're going to do that by copying and pasting these particular commands. So we're just going to do exactly that, copy and paste. In fact, I think we can probably get away with building a script actually. NVIDIA Container Toolkit, toolkit.sh, and I'm just gonna, just right click, paste. I'm gonna go back up, GG up, and it's hash bin bash, like that, and that looks good. Okay, what's the next command? Optionally configure experimental packages. So we've got update and install. So update, I like to do an and install, like that. Okay, and the next bit that we need to do is we need to do configuring Docker. So it's literally just copy and paste these commands. Okay, and then right quit, chmod +x, NVIDIA Container Toolkit, and just run that. Bash. Oh, okay, I made a slight mistake in which I said ib bash because it's very faint on my screen. But essentially it's bin bash, so it should be hash !bins/bash, and right quit that back out, and then run it again. And that will enable the script to now run and install the NVIDIA Container Toolkit. So there we go, that looks good. And now all we have to do is a docker compose -f, so it would be docker compose -f, and it should be a docker compose Olama GPU, and it's up -d, which means we run it in detached mode, and that should come online. I need sudo, so sudo, and version attribute is being ignored, which is fine. Now this will download Olama and the rest of the GUI components. So I'm going to wait for it to conclude, and then I'll unpause the video. Okay, so we're back, and as you can see, the containers have started. So a couple of things we need to do now. Sudo docker ps and type the password in. And as you can see, they're all up, which is great. So that's our first check complete. The next check is to check the logs. So sudo docker logs, and we're going to check the Olama container. Okay, so what we're checking here is to check whether or not it's loaded up the okay, I didn't expect it to create a key of any kind, but fair enough. What we're checking here is checking the compatibility to see if it's detected our GPUs, and I can see that it has. We've got two different IDs here for things like inference. So what it does is it's checking to see that these GPUs exist, and if they do, it will offload that particular model onto the GPUs for inferencing. Okay, that's why it says inferencing compute. I can also see that the libraries have been found. So we've got CUDA 11, CUDA 12, CPU, and CPU AVX2, which is what our CPU supports. These are the instruction sets that I was talking about earlier on. So that to me looks like it's working fine. Everything seems to be in, which is good. So what that means now is that we have to load up the particular language model that we want. So I'm just going to go off and do that to find the command, and I'll be with you shortly. Okay, welcome back. So this is Dolphin Llama 3, and the command that we want to run is Olama run Dolphin Llama 3 70 billion, which is the model that I'm going to use. You can use different models. We have 8 as well in here, so this is a slightly lower model, which means that it has lower parameters. So the reason why I'm using 70 billion is because it's a larger model, which means that the data set is bigger, which means that it can answer more questions. And I've more or less got the compute power to run this particular model, albeit very slowly. And on top of that, it means that it's less prone to not bias, but fuzzy logic. What's fuzzy logic, I hear you ask? Well, it's the AI getting confused, essentially. The more parameters that it has, the less likely it is to be confused. But it takes more time for it to think of an answer because it's going through loads of different decisions before it comes up with an answer. That's why it's really important to have a good GPU within the system. In my case, it's P100s. Some people may have RTX 8000s or even V100s for this exact purpose because there's more VRAM in the system, which means that the model itself, which is Llama 3, can be put into these GPUs and run exceedingly fast because it's using that VRAM. Okay? So let's copy these commands and let's go back to our terminal, where we'll then do a docker exec -it Olama, and we'll type Olama run Dolphin Llama 3 70 billion. And in my case, I forget to add sudo, so I'm going to add that at the start of the command. Okay, and that will pull the manifest, which means it will pull the model. And as it's pulling the model, remember, it's a 40 gigabyte model. It's going to take some time. Okay, so I'm going to let it do its thing. And once it's done, I will also pull in Qwen 2.5. And that means we'll have 2 models loaded in. So that way, when we see the web interface, we can interact with these 2 models. Okay, so I'll see you in a bit. And I'll unpause the video once those 2 models are downloaded. Okay, so I've just finished downloading Llama 3, the model, and you'll be presented with this particular prompt. Now, this is actually you interacting with the model. This is you interacting with the AI, essentially. Okay. So I'll be specific and say that you're interacting with the model, but a lot of people would say you're interacting with the AI. Okay, so you think about it as ChatGPT, you're on the right lines, although strictly speaking, I wouldn't necessarily call it that, but okay. here's the thing. So now you can type something in here to see if it responds, right? So we could ask it a question. Let's say, what does, okay, let's do, what does QNH stand for and mean in aviation? Okay, so we've asked it a question. It's thinking, it's going through its brain, it's trying to understand what it knows about QNH. What does QFE mean? That sort of thing. So let's see if it gives us a response. So definitely taking some time here. Bearing in mind it is a 70 billion parameter model. So I'm not expecting results straight away. It does take some time for it to process, which is why the result is going to take time, because it's processing and it's thinking. But I think in real time, it's going to take a bit of time. So just to show kind of how long it does actually take, I'm going to keep the video running in record mode. Normally I'd pause at this point, but I'm curious to see how long this is going to take. So to see that, it's better if I leave the video recording to see. So I'm curious now, and I want to see if we really are utilizing GPU. It says we are in the logs. So hopefully this doesn't take too long. I'll be hard pressed for it to take so long. Right, okay, but there is one thing we can do is if we go back to our server terminal, let's see if we've got any load on it. I'm not seeing any load in the software side of things. Okay, what about on our host? Are we seeing any active load on our host? As we should be. So 192.168.4.10. And I've typed my password wrong. Is that correct or was that wrong? Wrong. Okay, let's try that again. Okay, cool. Let's do a htop, and I'm not seeing anything there. What about nvidia-smi? Okay, we've got two processes, which is good. A little bit of movement on the GPU, but nothing major, so it's still thinking. And this is one thing that I've not quite understood in AI, which is, well, you can have a htop in here, and you can get maybe one or two threads running, but the general system is idle. If you've got any kind of reason as to why that is, I'd love to hear it in the comments, because I'm quite curious as to why a 20-core system with two P100s is kind of idle on a large language model. Like, what's it doing? Like, there's no utilization. So does that just mean it's utilizing the memory in the process? Is that the idea? I mean, I would have thought it would have made use of more resources, but apparently that doesn't seem to be correct. So what's it doing then? Is my question. And I don't know. I have no idea what exactly it's looking for at this point. Because every single feature that I've got is now on, which may mean that the memory is slow, but on the P100 it's HBM2. So yeah, I'm not sure what exactly it's doing. I've been told it's to do with the GPU going back into RAM, but there's nothing on the utilization and the memory usage is too low. But we have one character, a Q, Right, okay. Are you going to tell me what QNH means? Are you going to tell me? Come on. I know we have disk space. I gave you 400 gigs, so we got 360 left. But this is one of the generic problems which I've had with this particular language model is that sometimes it's hit and miss as to how many you get. Sometimes it's good, sometimes it's just bad. Like in this case, it's just been pretty bad. But if I say hello or testing, it'll be fast. So it's a bit weird. See if it goes past this. Maybe not. So what I'm going to do is I'm going to just pause it and see if it goes past. Okay, I decided to restart the entire system because I don't think it was working correctly and it was way too slow. I tried it even on 8 billion parameters and it was just far too slow. In fact, it didn't even get through the prompts. So I've asked it in 8 billion, I've asked it in 7 billion and quantize 4 with an instruct, and it was basically the same, just not working at all. But the thing here is that the models are loaded. So if you do find yourself in a situation, what I found was that the graphics card isn't working correctly. So in other words, it's loading the model into memory, into the graphics card memory, which is the VRAM. And from there, it's trying to do the computation. So in my case, my P100s are not up to the task of doing AI because I haven't got any tensor cores inside of the GPU, which is very, very bad. So I've decided to restart it because I have seen it work faster than that on 70 billion. So I'm going to give it another go. And this is what I'm going to do. I'm going to get rid of all that. I'm going to do a sudo docker ps. Like that. And I'm going to go to 8080, which is where the web UI is. So if I go to 8080, and by the way, this is like one of the cards that we should have inside of the system, which is an RTX 8000. I've been told that V100s are better as a Volta grade, which is the one before. I could have some A100s in there as well, which I think if I manage to get some donations or something, I could have a look at. But for now, I'm just going to go to the site, which is on 10, and I'm going to go to 8080. See, this is the web UI, the Olama web UI. Update, and we should have the few models there, which is great. So this is a quantized 70 billion model. I'm going to try maybe with, let's go with the Olama model. I think that's basically the same model as what I had. Dolphin Olama 3, Q 4.0, because it's got the most tensors. So it says, even though there's no tensors on the system, which I don't quite get, but okay, fine. And we're going to do, what is QFE in aviation? And I'm expecting this to take a long time because the graphic card is not that great. I would have hoped that it would use the CPU at least, but for some reason it doesn't do that. So I might have to change my CPU to get it working properly, which is very, very strange, but it's just what it is. So this could take some time. But essentially, that's the way that you would interact with the AI. You'd put a prompt in, and then it would give you an answer over a period of time. So yeah, that's basically it. I could theoretically speed this up a little bit. Oh, there we go. See, now it's going in straight away. And it's actually right. It's actually it's wrong. That's QNH, not QFE. Barometric pressure at runway. Oh no, it is right. It's at runway level. Yeah, that's correct. So this is what I'm saying, that sometimes it's a bit strange. Like sometimes it will just work straight off the bat, and other times it just won't. Yeah, so it's something that you have to kind of be mindful of. You can even load up pictures on this as well, I think. So you could upload some files. I don't have any here on hand. Let's see, let's see baby. I like elephants, right? So let's say baby elephant. Let's see if it can identify an elephant. Oh, we don't need to do that. We can just copy the image. And let's go over here. Right, this will be interesting because I'm not tested image recognition. Please provide a description. Oh, okay, so this is not a multimodal. So what that means is that the actual large language model doesn't support image recognition. That can be fixed. It's just a case of downloading the new model like Lava, I think it's called, and then that would fix that particular issue. So yeah, this is pretty cool. Let's see if we can do one more. What is QNH in aviation? Aviation, right? Because this is the one I got stuck on. So let's see if we get stuck again. Might do. Oh no, there we go, pretty quick. So this is where it gets weird. Like it doesn't always utilize all the system resources I've found. And I'm not sure if that's a bug or a feature or what that is, but when it does, it works really well. So yeah, I mean, we could say there's another Q code used in aviation represents the barometric pressure at mean sea level, which is correct. QNH does represent that. Yeah, so we can say let's do another one. What is the difference between a METAR and a TAF, right? So this is another aviation stuff. What's the difference between a METAR and a TAF, and what do they mean? So this is a slightly more complex one. Let's see what it does. Here we go. So a meteorological aerodrome report, which is correct, and terminal aerodrome forecast, which is correct, are both weather reports used in aviation, which is correct, but they serve different purposes. Meteor provides current real-time weather condition at an airport, including temperature, dew point, wind direction, and speed, visibility, cloud cover, and any significant weather phenomena. Pilots use this information to make decisions about flying conditions, which is correct, they do, and approach different departures. TAF, on the other hand, is a forecast of expected weather. That's correct. That's really, really well put, actually. I'm impressed. One restart later and it works. I don't know what to tell you. It's just technology. So yeah, that's how you utilize AI within Olama. And of course, like you can switch between different models as well. So you can go here. Like I can go to the 8 billion model now and say, you know, I want an 8 billion model answer. I don't know, describe. Let's see, something that I would know. Let's see, describe Koh Samui, right? Because I like Thailand and I like Koh Samui. So yeah, try Koh Samui. See if you can do it on an 8 billion model. So it has to dump the old model, put the new model in. So this could take a bit of time. It could get confused. Interesting. Oh, okay, yeah, here we go. So even quicker still. The reason why this is quicker is because it's an 8 billion parameter, so it's less loading in memory. This is actually running off the GPU, believe it or not. But it seems to work better in the context window, which is so strange. Yeah, that's really interesting. So what about, I wonder if maybe, what about the instruct model? I'm curious to see if the instruct model works now. Make a Pac-Man game make a Pac-Man game. See if it works. So we know 8 billion works the best, which makes sense because it's a smaller model. So it loaded completely within the GPU. Instruct should use the CPU as well, in theory. But again, clutching at straws with this one. And then we've got a quantization of 4. That's what Q4 means. It's a quantization, which means that the model's been sort of optimized. I wouldn't say it's been cut down. It's been more kind of optimized for different purposes. So that's usually what it means. In fact, why don't we ask the AI what instruct means? That would be fun, right? So it's taken a bit more time with the instruct model. That's interesting. That's very interesting. So while that's loading, for whatever reason, it's taking a long time. I don't know why, but what does instruct mean for AI? Pre-trained model base and further training it onto a smaller, more specialized data set relevant to the task. So we're kind of we're almost retraining it. So it's a slightly more involved model, which is probably why it's taking a long time. So this is probably going to take the most time. So this is what we're going to do. We're going to take that. I'm going to put it back to 8 and see if it responds, which it doesn't. So it's stuck in the memory. Very interesting. What did it say about Kusma? Kusma is a small island located on the coast of Pangna province in southern Thailand. It's a part of the similar islands, I don't know how to pronounce that, which is known for its crystal clear waters. I don't remember it having crystal clear waters. White sandy beaches, it did have sandy beach, and vibrant coral reef. Yeah, that's true. No permanent inhabitants. Occasional tourists visiting as part of the day trips. Snorkeling. I disagree. It does. I'm pretty sure it does have permanent inhabitants. Coastal is often visited for its rich marine biodiversity. Yeah, snorkeling, scuba diving. Yep, correct. I'm gonna try and see if I can delete this, and then select the 8 billion model. Let's see if we can make a Pac-Man game with the 8 billion model, which should load up into GPU. So this could vary. It might get confused, or it might not. In theory, because it's a smaller model, it shouldn't. But it probably can. So let's have a look. nvidia-smi. No processors found, so it's got confused again. Interesting. Yeah, it's got confused. Because it should have loaded that model into the memory. So let's see, do a htop. Okay, it's spawning a few processors, but nothing in the memory, so it's gotten confused, which is interesting. There's no processors. It should have fired a process by now. Yeah, so this is what I mean. Sometimes it just gets confused. Sometimes it just gets confused, and it's just strange that it does. And I personally think this is a bug, because there's no reason as to why it shouldn't be utilizing any of the system resources. Right now, it should be using a lot more resources than what it's doing. So it makes me think that it's not able, there's an error somewhere, or it's not able to spawn correctly. Yeah, it's probably got confused on the old model, which is weird because it's not spawning more threads or anything. So in these sort of situations, I'm going to try doing a Docker logs. So let's do a Docker logs. See if we can get any telemetry. Of course, sudo. Nothing. Let's try Olama. Okay, it looks like there was a post to the chat, which is correct. It says 2218, so that's UTC, so it's like 12 minutes ago, which is wrong. Failed to allocate. It failed to allocate no CUDA capable device. Really, it wasn't able to locate GPU VRAM. Didn't recover with timeout. Ah, okay, there we go. There's the bug. There's the bug. It didn't recover with the timeout, so it wasn't able to allocate. So it thinks that there's no GPU devices here, which is why it's failing. So that's going to go into infinitum. Best thing to do is probably to restart the Docker containers, I think. So this is what I'm going to do. I'm going to do a docker compose restart. Of course, use sudo. And let's see if we can restart those Docker containers to see if it finds it again. We'll do a docker logs back on Olama. And there we go. We got them back in again. So we got the two GPUs being found. We have everything back up the way it should be. So if we go back and we go back to the 8 billion model, we should now be able to make the game of Pac-Man. Make a Pac-Man game in Python. Okay, and we should. There we go. Boom. Boom. So if we want more of a quicker experience, the main takeaway is that we can reduce the size of the model by reducing the size of the parameters. And that seems to work very, very well on older systems. And the reason why is because it can load the particular model. Right, this was only a 4 gig model. This wasn't anything massive, a 5 or 6 gig model. It can load that into the GPU. And because it loads it into the GPU, it's a very, very fast VRAM. And because of that, we're getting a lot higher tokens. In other words, we're getting a much higher response rate out of the model itself, which is why we're getting like this pre-made model. If we want something which is more accurate, then we should optimize for higher models. So for example, if I wanted a much more accurate web method, I could go towards the Dolphin version, or I could go for the Instruct version. The Dolphin version would be better because it's 71 billion parameters, as opposed to this 70.6 parameters. But we should bear in mind that the Instruct version is pre-trained data, which is the reason why it takes long. So yeah, I hope you've enjoyed this series. I know it's been a bit long-winded as well in terms of what's there, but there's a lot of things to take away from this particular sequence of events. So I hope you've enjoyed it. I hope you've learned something, and I hope that you can also have a look at some of these models as well. Just before we go, I've been told that there's another bit in here where you can kind of load additional models, and I'm trying to find it. There's a bit where you can load in additional models as well, which are not in the Olama bit. And I believe... Okay, that's pretty cool. I didn't know you could use that, but... One second. Okay, so I had a look, and it is possible to do in Olama. But I think the video is too long already. So I'm going to save that for another video, and then we'll have a look at something like 8 and 8, which is an RAG thing, which allows you to kind of use different APIs to call things like Slack, for example, or Quadrant, which is going to be really, really cool. But we'll leave that for another video because this is too long already. All right, cool. So take care, and good night, and goodbye, good morning, good evening, whenever you're watching. There we go.